So we're talking to a customer at the moment who has bought many different, many varied architectures over time. And one of the questions they've asked us is that in an x86 market, in an industry standard market, what makes us different? What is it that we do that is different?
So first of all, let's address industry standard. The reason that people tend to think that all servers can be the same historically is that they hang their hat on industry standard. And that's really more about the way server and enterprise processing actually integrates and relates to each other, and the standards with which they communicate, not about the way they're built. So there's nothing industry standard about the way they're built. There are probably maybe 40–50% of the components are industry standard: processor, memory and hard drive, but that does leave 50% which is unique in the server design, and that 50% delivers or is critical in its innovation and design in delivering the three critical aspects that are important to a customer. That's reliability, performance and efficiency of the server.
So let's just talk about reliability for a second. What is it that we do in the way these things are designed and built that delivers that reliability for a customer?
So we have some unique propositions at that point. First of all, we have a trademarked design implementation called CoolSafe. CoolSafe really deals with the way a server is constructed to maintain its ambient temperature. This is critical. The critical aspect of this is it delivers A, on the performance, and B, on the resilience and reliability of the product. So that's absolutely critical, and this encompasses not only the power supplies, but the fans and the fan speed, and also air path and air flow, and the way all the products, all the components within the product are maintained at a stable ambient temperature.
So we talked about the fact that actually the perception is that they're all the same, and actually they're not. There's only probably about 40% within that server that's the same. We talked about the fact that how we deliver the reliability. The other you talked about was performance. What is it that we do, or what is it that we deliver in the Primergy servers that we would say is different in terms of performance for Primergy?
So we talked about reliability in context of obviously availability. So in other words, is the server working? Is it functional? Then we also need to talk about how it dovetails in. So the design of the product, CoolSafe in maintaining the level of performance, in other words, peak performance within a server. So by maintaining ambient temperature, preventing step down, by ensuring that your implementation of power supplies are optimum, you can make sure then that you're delivering the best architecture to deliver optimum performance. And we've proven this through our design implementation. So we won awards obviously from Intel on our implementation of our NALM, as well as our Xeon 55 series processor, 54 series processor. We're a platform of choice with the RX 600 on Intel Xeon 7000 series processor. And we have 4 world records and 10 best-in-class performance records to prove that you can make a differentiated implementation and design to deliver high-performance servers. And then critically, the way those servers actually perform is underpinned by such technologies as CoolSafe, which maintain the ambient temperature and ensure those servers actually deliver optimum performance consistently under heavier workloads that are demanded by today's virtual infrastructures.
So we talked about the reliability underpinned by performance, but does that have a penalty in terms of cost?
Again, this comes back to design. It's design implementation. So efficiency is the third component you need to concern yourself with. So being able to then obviously run the systems cooler, have slower fan speeds. Obviously fans on each server actually increase power consumption and cost, and the impact then in the way the fan speed works and the overall impact to the ecosystem within the data center also impacts on the wider cost of running a data center. So first of all, principally the design implementation dovetails completely into the level of efficiency that's delivered within A, the component level within servers, and B, across the whole data center ecosystem. Then there's obviously a wider discussion on efficiency. So power consumption is one, the data center ecosystem is the other, and the third one then is obviously about social responsibility in terms of manufacturing and manufacturing process. So making sure also the efficiencies scale out, not only in the way you implement a consumer product within your data center, but how it was actually then delivered to you and manufactured for you. So that's very much about the end-to-end design processing. As a European-centric development and manufacturing capability within Fujitsu, we have a heritage over 21 years of delivering green and socially responsible manufacturing. We have our own recycling plant, and our designs and implementation and procurement and development cycles are very much controlled within Europe. So we understand that the efficiencies are not just within the product, but also the way the product's delivered to a customer and the way it's constructed for customers.
Okay, so you talked about efficiency, and partly you talked about power efficiency. I mean, do we have any stats to back that up? Can we quantify that for a customer on average?
Yes, our expected improvement on power efficiency is around 20% when compared to the industry standard on form factor. But it's and the way we deliver that is about the complete redesign of our portfolio product to capitalise on a convergence of technologies last year. So we're really maximising new power supplies, new chassis designs, new components, and also the way the actual product breathes. So for instance, the BX900, it's delivering less power, it's consuming more air through having a greater aperture and pulling more air through more slowly against competition. So the market leader would probably be moving about 300 cubic feet of air through a 10U chassis, would be with less power moving about 500 cubic feet of air. And the reason that's critical is we're looking at much higher density processing and compute, so it's important that you actually maintain that ambient temperature within the infrastructure, make sure you get peak performance. So again, it's that whole efficiency, performance and reliability quotient, and the only way you can truly deliver that is through implementation of leadership design. We've done that within the Primergy range and across the range.
So even in a high density compute environment like the Blade environment, we would expect customers to see reduced power and reduced stress on the plant.
Yep, higher density within a equivalent space. That means more blades per U, and greater efficiency and greater airflow through that form factor to deliver stability and consistent performance.